Very director and founder of C.A.S.T, which is Control and Automation Solutions Technology, that you will see coming up shortly on the screen, which is for all your automation systems designing, installation, consultancy and debugging, and PLC trainings. C.A.S.T is your one-stop partner. So basically, I'm here to run you through a steam valve PID control system that I designed using TIA version 13, which is totally integrated automation software that I will start right now, and I'll run you through a live program. So waiting for the program to start up, I'm going to open a steam valve PID control system. Meanwhile, I'll need to start my PLC simulator as well. Step 7 simulator. Okay, open project view. Right, my simulator, I'm going to place the view to always on top. And then on my program blocks, that ones that I designed in TIA, I'm going to simply download them to the simulator. Right, compilation, then load. I've finished and the program is successfully loaded. Now I'm going to click run to run my program. Yes, my program is run program and no faulted programs. Now on my program blocks, I'm going to toggle online. The green dots that should appear here will indicate that all my blocks have been loaded in online, right, which is good. Now I'm going to open the analog scaling block and I'll show you the temperature transmitter and the design of the program within the program environment. A temperature transmitter with a preferable input word of 288. That is the same code that I'm going to be using from my simulator, and then insert a standard engineering value of 27648. This is a decimal number that is converted by the PLC to the analog input module and conveyed to the PLC as a binary number. All right. Now I want you to watch what happens here on the output as we are going to put our monitoring on. Monitoring. Right, this is a scaling block. You want to see 150 degrees on your HMI, which is the human machine interface, but this scales it to a form that you can read. So the standard engineering value from 0 to 27,648 is converted to a form that the HMI can see as in the form of temperature, since this is our air temperature. So I'm going to slide my slider here. What happens here on the output side of the scaling block. Now I'm sliding. You see you've got 5 degrees there. And look at what happens to my standard engineering value on my simulator. It's increasing, By the time I reach 27,648, that is the full scale reading within the program. And on my TI portal, it's from 0, which is my minimum set point for temperature, to the maximum value of 150. This is the same value you will see in the HMI. Now I am also going to insert more input variables that I'm going to use for my simulation. I insert more and more variables. All right. Now we've got 288 up to 264. So I'm going to be entering them in orderly fashion. I need a slider, a decimal slider. And here my peripheral input word is going to be IW260. IW260. Okay. Why am I saying IW260? It is an analog input address that you will need for the pressure transmitter. You see there's 290 there. And then we go to level transmitter. You see there's 292 here. You see, we go to our HMI manual valve control. It's an analog again, 294. Okay, we go to our steam valve PID control block. This is going to be controlling the steam valve. Pressure transmitter. Okay. So we're going to be entering these in the 290. Okay, our maximum value, standard engineering value 27648. This is done. Here we enter again IW292. Then our slider is going to be a decimal slider. Okay, this is done again. We go to peripheral input word, which is IW294. Okay, go to our decimal slider again. Our maximum value is going to be 27648. I hope you're getting this. I'm going to show you during the simulation. So if we're 298 here, 290, 292, 294. Here also have to make sure my maximum value is 27648. That is standard engineering value for Siemens products within the software itself. This range will be scaled down or converted to a form that the CPU of the PLC can read. So we got to the next level. We check whether our analog input modules for the air temperature transmitter is responding. You see right here is written IW, which is input word 288. Our standard engineering value, as you can see here, is 27648. From 0 to 27648, which is scaled from 0 to 150 degrees. So if I push my slider, you see it's changing to 0. Now I'm looking for my temperature transmitter, maximum air temperature set point, boiler temperature transmitter. 296. So here I need to insert it's going to be what? IW 296. Enter. I look for my decimal slider. Maximum is going to be 27648 again. So I'm going to simulate again. Right, it's working. This is my temperature for my boiler. You see it's rising. Right. So remember, on the HMI screen, we're going to be having alarms. These are designed from comparators that will compare a set point against a minimum or a maximum that will trigger. As you can see in my program here, I've got a boiler temperature alarm. This point here is where I have a digital output, which is triggered by this comparator. So when I reach a set point of 250 degrees, I should get this boiler alarm. This will not trip the boiler. It will just indicate that a minimum, the first set point has been reached. Okay, so I'll simulate that as well, and you see it operate. You see the value is increasing. Check here on top of the comparator there. If I reach 250, I want you to see what happens. Yes, my alarm is triggered, you see. Okay. What happens? I've two set alarms over temperature, maximum threshold. This is at 260, 265 actually. So check here. Right now I'm at 250 degrees, and then this is my second set point, 265. What happens here at my boiler temperature trip? This has to trip the whole boiler. So I have to continue increasing my temperature. Check what's happening, 264, 265. Right now the boiler is tripped. So you see all this in the HMI. I want to show you the steam valve PID so that when you see the HMI operate, sorry, you understand where this is coming from. Right, this is my PID valve, and my set point is coming from the air temperature transmitter. You get a feel of all this. This is where the output from this block is fed to the PID control. So in fact, this air temperature is our process value measured by the PID against a set point of 100 degrees. So if my air temperature is 100 degrees, anything above 100 degrees, my valve should close. So now I have to activate the integral and proportional components of my PID controller. This I have to do through the simulator, which is 7 and 4. You see, my valve is now operating. It's now at 100% open because it's in automatic mode. If I activate from here, watch here on my arrow on input 0.1 digital input. If I activate, what happens to my 100? It goes to 0 because it's now in manual. You see. Now I need to raise my set point. What happens if I reach my set point? Okay. You see, my set point is 101 degrees. And what's happening to my steam valve? It's closing slowly. You see, 86. You see. So for you to get an understanding of all this, I'm activating the HMI screen so you can see all this process on design that I've done. All right, I'm starting my WinCC. Compilation in process. Right. Here we've got a steam valve PID control system designed by C.A.S.T. And this is a Siemens HMI screen. So basically, like I told you before, we cannot start the boiler while the valve is opened. So we have to switch our valve from automatic mode to manual mode. That is what I'm going to do. Right, that's the first port of call. 0. Here, the valve is closed. Now I'll take you through the basic operation principle of the whole system. This system has got manual and auto mode. In auto mode, we've got an automatic startup sequence of all the processes. Though I'm using a simulator, I have to be toggling up the digital inputs one by one. So we have this pump here. It is an inlet pump to pump water into the tank. And if we reach a maximum level of 500 liters, the pump will automatically stop. And this is the level indicator. After this, the valve is closed. It's in manual mode. It's 0% opening. Our stoker here in yellow, if you activate it, it has to push the burning coal into the furnace or the combustion chamber rather to heat up the water. So as we heat up the water, we will have an increase in temperature and also an increase in pressure as we start to produce steam. At a maximum of 5 bars, we have got an indicator here that will show green that our maximum pressure point has been reached. This will activate the blower to start blowing air through these coils of piping where in which the steam will be flowing to heat up the air being blown through these pipes, and our temperature indicator is here. Okay, so we have got indications here: our start button, stop button, and run system indication. Here we're going to start our boiler. It's going to be IMB1 here. We start our program. If I toggle here on our simulator, watch what happens at the HMI on the start button. It's going to be green, and our run system indicator is going to be green as well. And then you see our pump running. It's in red right now, and the inlet pump indication here on the HMI is red as well. We're going to start our boiler. We start. Check the system run indication and the start button. We assume that our pump is pumping water into the tank, and let's watch our indication, our level indicator. Yes, good. We've got water rising into the boiler, filling the boiler tank. Yes. So as we are filling our water in, if we reach a maximum of 500 liters, look at what happens to our inlet pump run indication, and here on the pump itself. Let's continue to increase the liquid level. Good, our pump is stopped. Now we need to start our stoker here in yellow. Good, the stoker is running and you can see the flashing green light. Our temperature will begin to increase as we continue to insert or drive burning coal into the boiler, raising the temperature of the water. Look at what happens at our pressure as the water begins to boil. Our pressure is on 2 bars, as you can see on the HMI. And then meanwhile, our temperature is also increasing. Our temperature of the boiler is increasing. You see, we've got 145 degrees Celsius. The boiling temperature of water is 100 degrees. And basically, we've got steam being produced now. So our pressure will continue to increase as well, up to 4. The moment we have 5 bars here, I want you to see what happens at our blower here. At your bottom right corner, that's your fan there. Look at your indication for the pressure in bars. As I increase the pressure, you see our air blower is now started. It is at this point that we manually open our steam valve from the HMI input on IW294. Look at what I'm doing. I'm sliding. We need a crack opening, 9%. Now we have got hot steam flowing through the pipe, and as the air is blowing through the pipes, the temperature should start to increase. Look at what happens to our temperature here of the air is 5 degrees. Sorry, 29. The moment you almost reach your set point of temperature, you should switch your valve to automatic, such that when your maximum temperature is reached, the steam valve action will start. At least 25% opening, and then we also have an increase in temperature. Somewhere at 70 degrees, I'm switching my valve to auto. I want you to see what will happen at the percentage opening of the valve here. I'm going to auto. You see, the valve is opening because my temperature here is still below the set point. Now let me watch what happens as I increase my temperature. 9800. You see how fast or how slow the valve will react to the change in temperature will be dependent on the error, which is the difference between the set point and the process value, or the measured value rather. So if I increase more, the faster it closes my temperature. If I increase to say 126, you see the valve closes quicker, and that will be dependent on my gain. You see, but at the moment I'm at 101. Look at what happens at my percentage closing. You can also view this within the analog data block. This is what I want to show you in the analog data block. You can see all the processes. You put this into monitoring mode. You check all this as it is happening. I'm in my analog block. This where the set points are. You see, you've got this. This is the percentage closing of the valve, as we are watching in the HMI. You see 24, 22, 21. That's the same you see here. 16, 15. You see, so it's actually written PID controller output to valve. You see, and here is my temperature output signal. All right, if I can take my simulator, watch what happens to this. You see, as I slide. You see, this is what you see within the program. This is my analog data block. I'll also show you from my what you see air temperature 102 is what you will see in TIA. Sorry about that. TIA 102. This is the same 102 you see here, which is the air temperature being blown from this fan past the piping, and you see. So thank you so much. This is the steam valve PID control system that I've just presented to you, and I give you a run through for all your automation systems designing, installation, commissioning, PLC debugging, trainings. C.A.S.T is for you. I'm here to give you all the data you need. Trainings, you can get in touch. My number you can see. That's C.A.S.T, Controlling Automated Solutions Technology, for all your automation systems, designing, installation, consultancy. I'm here. It's your one-stop partner in automation. If you want to know anything on PLC, I'm here to train. So thank you. It has been nice work.